In this video, we're going to be discussing the compound interest formula. It's an application of exponential growth, but it's with our money. So first of all, we need to know the formula. It will be given to you for your exam. So A equals P times 1 plus R over N to the N times T. But more importantly, we need to know what all those variables stand for. So let's start with that A. That's the amount that your money grows into after a certain amount of years. The P stands for principal. It's your starting amount. It's the money that you invest. The R stands for interest rate. We have to write it as a decimal. The N is the number of times your money compounds each year. And the T is time in years. So really important that you know what those variables stand for. So let's play a little Powerball and check the results. It appears you've won $50,000 playing Powerball, but you're a responsible young citizen. You decide that you're going to invest it in an account that's paying you 3.5% interest that's going to get compounded monthly. How much will you have when you retire at age 60? So you take that $50,000 and you just put away and forget about it. Well, here's our formula. We just need to know what those variables stand for and what we're looking for. We're looking for how much money we're going to have at the end, not the starting amount. So we're looking for that A in our formula. So let's see how much money we're going to have. P stands for the principal, the starting amount. That's our $50,000 that we just won. We're going to put all of it into the bank. And R stands for the interest rate that we're going to get, which we move the decimal 2 to the left and we use a 0.035. N is the number of times it compounds each year. So if it's doing so monthly and there's 12 months in a year, we'll put a 12 here. If it's doing it quarterly, we put a 4. Semi-annually, we put a 2. 365 would mean compounded daily, and you should have written all that down in your notes. And then to the N times T would be 12 times. Be careful that we don't think we put a 60 in there because we didn't win the Powerball when we were born. We won the Powerball, let's say at age 18. And so then we'd have had 42 years for that money to sit. So then it becomes the calculator's issue to calculate it. So in the top row, I've entered $50,000 times the quantity 1 plus 0.035 divided by 12 to the 12 times 42, exactly what I wrote above. And my calculator tells me that my money will have grown to $216,996.97, nearly $250,000. However, watch me change it a little bit. Had the wording said 6% interest compounded daily, I would have done the exact same calculation, except my 0.035 would become a 0.06, and compounded monthly, which was 12, to compounded daily would change that to 365. Notice my money amount nearly tripled, and it's that interest rate that does it. So that's it for our compound interest. Next time we'll talk about, well, what happens if it compounds continuously?